Good morning, everyone. In the last video, we have learned about that how to read a eye prescription card. And in this new video, we will learn that what is actually the distance vision correction, what is actually the near vision correction, what is actually the intermediate correction, and what is the characteristics of a near addition. So first of all, you have to keep it in mind that are distance correction or intermediate correction or near correction. These three types of prescriptions can be in any form, right? The distance, the intermediate, and the near correction can be in the form of the spherical correction, or in the plus spherical correction, or in the minus spherical correction. You know that we prescribe plus spherical in the case of hypermetropia, and we always prescribe minus spherical in case of the myopia, right? And we prescribe cylindrical correction in the case of astigmatism, right? We have different type of astigmatism, like we have simple astigmatism, we have mixed astigmatism, we have compound astigmatism, right? But so it means that if we talk about the distance vision correction, if we talk about the intermediate correction, if we talk about the near vision correction, these three prescription can be in any form: in plus spherical, in minus spherical, in plus cylinder, in minus cylinder, or in spherocylinder, or in the toric prescription as well. But we have to keep it in mind that the near addition, if we talk about the near addition, right, we have two different characteristics of near addition. The first one is the near correction would be always in spherical form, right? And the next characteristic is the near correction, or sorry, the near addition, I repeat, the near addition would be always in the plus form, the plus spherical form, right? The near addition would be always in plus spherical form. The near addition can never be in minus spherical, can never be in plus cylinder, can never be in minus cylinder. And the distance correction, as you see, the distance correction, as I said, the distance correction can be in plus spherical, in minus spherical, in plus cylinder, in minus cylinder, or both, right? Plus spherical minus cylinder, or minus spherical plus cylinder, right? The distance correction can be in any form of refraction. And now if we talk about the near correction, the near vision glasses, the near prescription is actually the combination of the two things, right? The first things is actually the distance correction, and the second thing is called the near addition. When we combine both of these prescriptions, the distance correction and near addition, when we combine both of these prescription, the resultant value would be in the near vision prescription for the near vision glasses, right? So it means that the near vision correction or the near vision prescription is actually the combination of the distance vision correction and the addition. You know that the addition is always in plus spherical form, right? And we have to add this near addition, which can be in plus 1, which can be plus 1.25 or 1.5 or 2, and we can go to plus 3, right? Spherical correction. And this near addition would be add in the distance correction, in the spherical correction of the distance prescription, right? We have to add this spherical correction of the near addition to the spherical correction of the distance correction, that this combination would be in the near vision prescription, right? So I repeat that our near vision prescription or near vision correction is actually the combination of the two prescription, right? First one is called the distance vision correction, and the second thing is the near addition, which is in plus spherical form, right? And if we talk about the intermediate correction or intermediate prescription, you know that the intermediate is actually, if I'm looking at the for distance, that is my for vision, right? And if I'm looking at my mobile, if I'm looking at my text, if I'm writing something, that distance is for my near vision, right? And actually the intermediate distance is actually between the for distance and the near distance. You know that the near distance is actually till, you can say 40 centimeter or 35 centimeter or 25 centimeters. It's according to the age, right? So in different age group we have different reading distance, right? But the intermediate distance is actually between the, you can say, for distance and near distance, right? If I'm looking at my desktop, if I'm looking at my screen which is away from my near vision distance, then that distance would be of my intermediate distance, right? Now the question is that why I need a separate pair of glasses for reading, why I need a separate pair of glasses for intermediate, and why I need a separate pair of glasses for distance. And to understand the logic behind that, why I need a separate pair of glasses for reading, why I need a separate pair of glasses for my intermediate correction, intermediate distance, and why I need a separate pair of glasses for distance, we must have some knowledge about the accommodation in presbyopia. And first of all, we will learn that what is actually the accommodation. You know that the accommodation is actually the increase in the plus power, the increase in the convexity of the crystalline lens. If I want to look at my mobile clearly, if I want to look at my screen clearly, then my lens must exert accommodation. The lens have to exert accommodation. The lens have to increase its convexity. The lens has to increase its plus power. And that increased plus power would help me to see my phone clearly, to see my screen clearly. So it means everyone need a plus power, additional plus power to read his phone or her phone, to read his or her screen, right? So plus power is actually the basic need to read, actually the accommodation. That plus power, that increase in plus power is actually the accommodation. The process is called accommodation. So accommodation is very necessary. Accommodation is very essential to read my phone, to read my screen, to write something, right? So for any reading purposes, for any reading task, my lens have to increase its plus power. It means my lens has to exert accommodation. So that's why we always, because the accommodation is actually, right, the accommodation is actually in the plus spherical form. The lens is increasing its plus spherical form. You have to keep it in mind. This is important point, that why we always prescribe addition in plus spherical form. This is the question, right? That why we always prescribe addition, near addition in plus spherical form. And the answer is that accommodation is always in plus spherical form, right? So actually after presbyopia, right, that near addition is actually the substitute, that near addition is actually the replacement of the accommodation, which is in plus spherical form. So that's why we always prescribe near addition in plus spherical form. And now if you talk about the presbyopia, you know that the presbyopia is actually the loss of accommodation. But the condition, the loss of accommodation can occur in any of the age, in every age, like in newly born baby, or you can say in 25 years of age, in 15 years of age, in 20 years of age, right? But what is actually then what is actually the presbyopia? The presbyopia is actually the loss of accommodation at the presbyopic age, at the 40 years of age. Actually this is a normal physiology. The presbyopia is actually a normal physiology, right? With the passage of time, with the passage of the age, right, our face get wrinkled, right? Our muscles get shrinked, right? Our muscles got weaken and weaken. So this is the presbyopia. That loss of accommodation is actually the process of aging. This is a normal physiology, right? We have, you know that we have a ciliarus muscle in our eye, right, which actually control the accommodation process of the crystalline lens. So with the passage of time, with the passage of age, that ciliarus muscle will get weakened, right? So that weakness of the ciliarus muscle will let the lens do not exert accommodation, right? So that's why, so with the passage of time, due to the aging process, if the lens got weakened, if the lens do not exert accommodation, if the lens lose his accommodation, that loss of accommodation with the passage of time due to the age is called presbyopia, right? But before the 40 years, like in 15 years, like in 25 years, in 35 years, or in the newly born, we have sufficient accommodation, we have sufficient you can say plus power to read our material, reading material, right? We can read our screen, or we can read our mobile phone easily, because we have sufficient accommodation, right? But with the passage of time, at the presbyopic age, at the 40 years of age, we lost all accommodation. So that's why we feel difficulty in reading. So this is called presbyopia. And now we will learn that what is actually the distance vision correction, right? As we have discussed, that what are the characteristics of distance vision. As I said, the distance vision correction can be in plus spherical form, just plus spherical form in case of hypermetropia, or in just minus spherical form in case of hypermetropia, or you can say in both +1 spherical or with -1 cylinder, right, at any of the axis, the distance correction could be in this form. This is a paracylindrical, or you can say with minus sphere and with plus cylinder at any of the axis. So it means that the distance vision correction, the prescription of distance vision can be in any form, in plus spherical form, in minus spherical form, in spherocylindrical form. And the same case is with the intermediate. And now if I talk about, you can say, the near vision correction, the prescription of a near vision glasses, this is actually the combination of, as I said, this is a combination of the, you can say, distance vision correction and the near addition, right? Suppose we have distance vision correction is +1 with -1 cylinder at 90 degree, right? This is prescription of distance vision of any of the patient, right? And if, as I said, the near addition is always in plus, convex and spherical form. You know that we prescribe different near addition in different age groups, right? That is a different topic we will discuss in the next video. So near addition is always in plus spherical form, right? And to gain the prescription of near vision glasses, we have to add this near addition in the spherical correction of the distance correction, right? So the spherical correction is +1 with -1 cylinder at 90 degree. So now we have nothing to do with the cylindrical correction and the axis of the cylindrical correction. We have nothing to do with, right? We just have to add this near addition prescription in the spherical correction. Make sure in the spherical correction of the distance vision prescription, right? So the what is actually the spherical correction? It's the distance vision is +1. So +1 and +1 addition is +1. So the answer would be +2, right? So the near vision prescription of that eye would be +2 with the same cylinder and axis. We have nothing to do with the sign of the cylinder. We have nothing to do with the power of the cylinder. We have nothing to do with the axis of the cylinder. We have to write as such, right? So we will write -1 cylinder at 90 degree. So this is the prescription of, or the prescription for the near vision glasses, right? So we will discuss the next example. The prescription of the distance is -2 cylinder at 90 degree. This is the prescription of distance glasses of any of the patient, right? And the near addition is, you can say, +3, right? This is addition. So we want to gain the correction of the near vision glasses, right? So as you see that this distance vision correction do not have any of the spherical correction, right? So it means it does not have any spherical correction. So the sphere of this prescription is 0. And what is the cylinder? Is -2 cylinder at 90 degree, right? So to gain the near vision correction, to gain the near vision prescription, we simply have to add this addition in the spherical correction. So this prescription do not have any spherical correction. So we will simply add +3 into 0 because there is no any spherical correction in this prescription. So the near addition would be, or the near vision prescription would be +3 with same cylinder and axis. So this +3 with -2 cylinder and at 90 degree, this is the prescription for the near vision glasses. So as I told that the near vision, this near vision is actually the combination of the distance correction, which is -2 with 90 degree, and the near addition, right? So the near vision prescription is actually the combination of the near addition and the distance correction. So another example. Now most of the people will get confused while prescribing near addition in the myopic correction. So we have distance correction with -2 of myopia, right? So if the addition of the patient is, you can say, 40 years, so you know that in the 40 years we always prescribe +1 spherical as near addition, right? So we have to add +1, which is near addition, in the spherical correction. -2 is spherical of the distance vision correction. So we simply have to add this +1 near addition in the spherical correction of the distance correction, right? But algebraically, you have to keep it in mind. We will add the near addition with the spherical correction of the distance vision algebraically, right? You can see the sign with the near addition is plus, and you can see the sign with the distance vision spherical correction is minus, right? So if we add +1 in -2 algebraically, and you know that plus minus is always minus, right? So we have to subtract +1 from -2, and the answer would be -1, right? So the distance correction was -2 spherical, and the near correction would be -1 spherical. After addition of +1 into -2 algebraically, the answer would be -1, right? So the distance correction of that myopic patient would be -2, and near correction would be -1. As you know that we have to reduce the plus power. Sorry, we have to reduce the minus power to prescribe near vision glasses in myopia. Right? Another example. So we have distance vision correction, which is -3 spherical with -1 cylinder at 90 degree, and the age of the patient is post, you can say 50 years. And with the tentative method, we always prescribe +2 more or less in 50 years of age, in 50 years of presbyopic age. So the near addition would be +2, right? So we have to add this +2 near addition in the spherical correction of the distance vision correction. So if I add +2 algebraically, so the sign with the near addition is plus, sign with the distance vision correction is minus, right? So plus and minus is always in minus. So we have to subtract +2 from -3. The answer would be 1, and the sign would be in minus because the minus sign is with a greater value, right? So we will put the sign minus, right? So when we add this +2 into -3 algebraically, the answer is -1. So the near vision correction would be -1 spherical with the same sign, with same cylinder, and with same axis. We have nothing to do with the cylinder, and we will write as such. So this is the near vision prescription. And now we will learn that how we can find the intermediate correction, right? If a person came with a prescription card having distance vision correction and addition, you know that always the prescription card carries the distance vision correction and addition, near addition. We ourselves have to find the correction for the reading glasses and for the correction for the intermediate correction. So we will learn that how we can find the intermediate correction if we have a prescription card with two components, a distance correction and near addition. As you can see, we have distance vision correction. The patient is 6 by 6 with correction of +1 spherical, for example, right? And the age of the patient was 50 years and we prescribed +2 near addition. This is addition, right? The addition is +2. So if we want to find out the near vision correction, then we simply have to add this near addition into the spherical correction of the distance vision, and the answer would be +3. But this is prescription for the near vision glasses. But if we want to find the intermediate correction for the same patient having the distance vision correction +1 and having addition +2, then what will we do? We simply have Now this is for intermediate vision, right? If our patient wants spectacles for his desktop, for example, right, then what would be the eyeglasses prescription? So we'll simply have to reduce the addition, right? Because the reason is the intermediate distance is actually a little bit far away from the near distance. If I read my phone, if I read my text at my near distance, which is at 40 centimeter, or you can say 35 centimeter or 30 centimeter, it depends on the age, right? But if someone needs glasses at intermediate distance, like at desktop uh, setting of a table, then we have to reduce this near addition, because the near addition is for the reading, right? This is not for the intermediate. So we will set his prescription according to the distance, right? So we will have to reduce this plus correction, right? As you know that if you recall the process of accommodation, as this object will come closer to me here, then as greater plus power I will require, right? If this object will go away from me, then plus power will go down, will decline. Because if this object come closer here, I require more and more plus power. If I push this object away, then my plus power will get reduced to see this object clearly. So it means if the object is closer to me, then I require most of the power, the greater plus power. If this object will go away from me, then the plus power will go decrease. So it means if I require correction for reading, then addition will be in higher plus power, right? And if I need for intermediate distance, then I required less of the plus power. So we have to reduce this plus power, right? So our full correction of the near addition is plus 2. We have to decrease it. If it is plus 1, then we will take half of it. This is plus 2 and it would be plus 1 for intermediate correction. And now this half of the near addition will add in the distance correction of the spherical correction of the distance vision. So plus 1 will add in plus 1, and the intermediate glasses prescription would be plus 2. So it means if I required intermediate correction, if I require intermediate glasses, then I simply have to take half of the addition of the near addition, and that half of the near addition will add in the distance correction, but algebraically. We have to take care of the signs. If both near addition and both spherical correction sign are same in plus, then both of the power would be in plus form, right? Plus 1 and plus 1 would be plus 2. Now we will find another intermediate correction. The distance vision correction is minus 3 with 0.5 cylinder at 90 degree, right? And near addition is plus 2, right? So I want to find the intermediate, the correction for the intermediate distance. So simply we have to take half of the near addition. What would be the half? Plus 2, it would be plus 1, right? Because I need for intermediate correction, right? So plus 1 would be add in the spherical correction of the distance vision correction, right? But remember, the sign with the spherical correction of the distance vision is minus. So we will add algebraically. This is minus 3 spherical of the distance vision, and this is half of the near addition, which is in plus form. We will add algebraically. The minus sign is with the minus 3, with the 3, and plus sign is with the 1, right? And plus minus would be in minus. So we will have to subtract. We will subtract plus 1 from minus 3, and the answer would be minus 2, right? So our near vision, sorry, intermediate vision correction would be in minus 2 with same cylinder. So this is our intermediate vision. Hope this is clear. We'll see you in the next video.